replacing existing metal halide light poles with energy-efficient alternatives can significantly reduce electricity costs. Several options are available, each with its own set of advantages and disadvantages. Firstly, LED lighting poles are extremely energy efficient, consuming up to 80% less energy than metal halide. They also boast a long lifespan exceeding 50,000 hours and require minimal maintenance. Additionally, LED offer excellent color rendering. However, the upfront cost of LED lighting poles is high compared to other options. Secondly, solar-powered LED lighting poles offer zero energy consumption by utilizing sunlight to charge batteries. This eliminates ongoing electricity costs and promotes sustainability. Solar lighting is particularly suitable for remote areas without grid access. The disadvantages include a higher initial investment in grid-connected LED lighting, along with the potential need for additional infrastructure such as batteries and charge controllers. Thirdly, high-efficiency metal halide poles consume less energy than standard metal halide poles, achieving reductions of up to 25%. They also provide good color rendering and have a relatively low initial cost. However, they are not as energy efficient as LED or solar-powered lighting, and their lifespan is shorter than that of LED. To enhance parking lot illumination, consider these options. Firstly, knuckle adapters for shoebox heads are easy to install and redirect light to specific areas as needed. They are also an inexpensive solution. However, they might not provide sufficient illumination for all areas of the parking lot. Secondly, additional light poles with LED luminaires ensure uniform and adequate illumination throughout the parking lot, enhancing visibility and safety. The trade-off is the need for additional infrastructure and a higher initial investment. Implementing lighting control measures can further optimize energy savings. Firstly, photocell control automatically turns lights on at dusk and off at dawn, reducing energy consumption during daylight hours. However, photocells may not be as effective in areas with overcast skies or significant light pollution. Secondly, an astro time clock provides more precise control over lighting schedules, allowing for programming to turn lights off after specific hours when the parking lot is unoccupied. Proper programming is essential for optimal performance, and it may not be as energy efficient as photocell control in all situations. When selecting replacement fixtures, consider both wattage and lumen output to ensure adequate illumination while minimizing energy consumption. Calculate the payback period for each alternative to assess its financial viability. It's recommended to seek professional advice from a qualified lighting designer or electrician to design and install the most suitable lighting solution. Factors such as initial cost, energy savings, maintenance requirements, and lifespan should all be considered. The existing system uses 400-watt lamps with 2 heads on each pole, so that's 800 watts per pole. With approximately 10 to 12 poles, the total wattage consumption is between 8,000 and 9,600 watts before any ballast losses are factored in. Let's look at some example calculations. If the lights are on for 10 hours per night, that's 3,650 hours per year. At an average electricity cost of, say, 15 cents per kilowatt hour, the annual cost is calculated as follows. Firstly, for 8,000 watts, the calculation is 8 kilowatts times 3,650 hours times $0.15, which equals $4,380. Secondly, for 9,600 watts, the calculation is 9.6 kilowatts times 3,650 hours times $0.15, which equals $5,256. Switching to LED could reduce energy consumption by up to 80%. A comparable LED fixture might use only 160 watts. With 10 to 12 poles, the total LED wattage would be between 1,600 and 1,920 watts. The annual cost savings would be significant. Firstly, for 1,600 watts, the calculation is 1.6 kilowatts times 3,650 hours times $0.15, which equals $876. Secondly, for 1,920 watts, the calculation is 1.92 kilowatts times 3,650 650 IOs times $0.15, which equals $1051.20. The energy savings would be between $4,380 minus $876 equals $3,504 and $5,256 minus $1051.20, which equals $4,204.80. Solar-powered LED lighting poles completely eliminate the electricity cost, but the initial investment is higher. The payback period depends on the cost difference and the amount of energy saved. Consider a scenario where the LED pole costs $500 each. The total for 10 poles is $5,000. If the annual savings is $3,500, then the payback is $5,000 divided by $3,500, which equals 1.43 years. High-efficiency metal halide lamps offer a modest energy savings compared to standard metal halide. The reduced restrike power consumption would only realize a small amount of savings. It may not be worth the expense. Upgrading the lighting controls makes sense. An astronomical time clock is a good option to turn the lights off completely after a certain time. Make sure it has battery backup in case of a power failure. Also, consider the environmental impact. Reducing energy consumption reduces the carbon footprint of the church. LED lighting has a longer lifespan, reducing the frequency of bulb replacements and associated waste. When selecting LED fixtures, consider the color temperature. A warm color temperature is typically preferred for parking lots. It provides a more inviting and comfortable atmosphere. Look for fixtures with a color rendering index greater than 70 for better color accuracy. This makes it easier to identify objects and people in the parking lot. Check for dark sky compliance. This ensures that the light is directed downward and does not contribute to light pollution. The fixtures should be properly shielded to minimize glare. The lighting design should take into account the specific needs of the church and its parking lot. For example, if there are areas where people walk, those areas should be well lit. If there are security concerns, consider adding motion sensors to turn on the lights when someone enters a parking lot. Consider the local climate and weather conditions. In areas with heavy snowfall, the fixtures should be mounted high enough to avoid being covered by snow. It is recommended to consult with a qualified lighting designer or electrical contractor to develop a comprehensive lighting plan. This will help ensure that the new lighting system meets the needs of the church and its parking lot. Review the wattage of the existing ballast, as it can add significant watts to the overall lighting load. If the original ballast is rated for 480 volts and there has been a conversion to 277 volts, there may be an inefficiency in the current draw. It might be beneficial to replace the ballast as well. Verify the line voltage for the existing lighting system. If it is 480 volts, consider the additional cost to rewire for a lower voltage such as 277 or 120 volts. This could potentially save money on the lighting fixtures. Consider the existing wire gauge in the circuit. It may be possible to add additional fixtures to the circuit without upgrading the wire. However, be sure to perform a load calculation to ensure that the circuit is not overloaded. Consult NEC Table 310.15 for allowable opacities of conductors. The church should consider performing a lighting audit to identify areas where energy can be saved. The audit should include a review of the existing lighting system, as well as an assessment of the lighting needs of the church. Once the audit is complete, the church can develop a plan to upgrade the lighting system. This plan should include a timeline for the project, as well as a budget. The church should also consider applying for rebates or incentives from their local utility company. Many utility companies offer rebates for energy-efficient lighting upgrades. Make sure to calculate the return on investment for each lighting option. This will help the church make an informed decision about which option is best for them. Consider the maintenance cost associated with each lighting option. LED lighting typically has lower maintenance costs than other types of lighting. Metal halide lamps typically have a shorter lifespan than LED lamps and will need to be replaced more often. When making a purchase, ensure that the company carries insurance. Check references, read reviews, and consider only established lighting specialists. When receiving quotes, ensure there is a detailed plan of action on how they intend to perform the work. Verify that the company only employs licensed electricians.